Alright, good night, and I will be doing paper 2 for chemistry January 2020. So let's get started. So it says the rate of reaction of magnesium with a solution of dilute sulfuric acid can be investigated by measuring how long it takes for a specific volume of gas to be produced. Andrew conducted 2 experiments to investigate factors that can affect the rate of reaction between magnesium and sulfuric acid. In experiment 1, magnesium strips were added to 50 centimeters cubed of 2 moles per dm cube sulfuric acid in a 250 centimeter cube conical flask. The volume of gas produced over a period of 6 minutes was measured, and some of the measurements as shown in figure 1. The data recorded for experiment 1 are summarized in table 1 on page 6. Alright, so we have the 5 syringes that we're supposed to look at, and it says first to define the term rate of reaction. Well, the rate of reaction is a measured change in concentration of a reactant or product with time at a given temperature. So I'm going to write that down. Okay, so that's for 1 mark. Then we have some easy stuff to do. We just have to remember, as we're going down the thermometer here, we're increasing. Okay, so it says from the gas syringes displayed in figure 1 on page 5, record the volume of gas produced in the appropriate spaces in table 1. The volume at times 0, 5, and 6 minutes have already been recorded. Alright, so we're looking at 0.5 minutes or half a minute. We see here this is 0, this is 1, 2, 3, 4, 5, 6. So each point is 1 point. So this is 6. And at 1 it's 11. At 2 it's 16.5. At 3 it's 19. And at 4 it's 20. So these are the numbers you should have. So yes, so you see right after 10 it will be 11, and then we know that this is 15 right here, because you say 11, 12, 13, 14, 15, 16, as in between 16 and 17, so that will be 16.5. Then we have the point just above 20, that's 19, and right on 20, right? So those are the numbers you should have. So moving right along, we have our numbers here, and I put them here so that we could just plot easily. So when we look at this, you would see that every 10 spaces is 5, so therefore every 2 little spaces will be 1. How we calculate that? Simple. We have 0, and so it's a 5, whereas when it's a smaller number from the larger number. So this is 0 here, and this will be 5 minus 0 over 10. Right, and we know that 5 over 10 will be equal to a half. So if 1 space is a half, every 2 spaces will be 1. Okay, so that'll be 1, and you have to look really closely. This will be 2, and then we have here, this will be 3, and then we have 4, right? All right, so we know that at 0.5, so in here now, to figure out how many each space is, I mean, it's obvious that this is half, right? But to figure this out again, you would say, well, 1 minus 0 divided by 10, and this will give you a tenth at 0.1. So each point is 0.1, so this will be 0.1, 2, 3, 4, 5. This will be 0.5, right? So at the 0.5 mark, we have 6. So put 6, and we right here, this is 6, and we just follow the trend. So the dot, the first one is 0, and it's a dot circled, you know, so we're going to follow all through. And then when you have 1, it's 11, so this is 11 right here. And at 2, we have 16.5, this is 16, and so this is 0.5. At 3, we have 19, so that's just a little under 20. and at 4 we have 20. Awesome sauce. So now we have plotted all our points, and that will give us, I think, 5 max. 5 points, 5 max. Okay, so now I'm going to use a different color for the thread line. I'm going to try my best to draw a curved thread line to these points. Ooh, that's my best. Alright, so it says from your graph determine the time taken for the reaction to be completed. But the reaction is completed when you reach a plateau. So once you see you reach 20 and then every minute is 20, 20, 20, that means the reaction is over. It's nothing else is being produced. So it asks for time. So we're gonna do something called extrapolation. So I use my purple marker here. I'm gonna extrapolate across from 20, and you should use a ruler for this. Across from 20, and this is the first instance when it stopped, and then you're gonna come down from 20 down to the time axis, which is the x-axis, and you would see that the reaction was over after 4 minutes. So you write 4 minutes right here, right? I'm gonna write the whole word because it would have to write the whole word. Then we have said during which time interval was the rate of reaction the fastest. Alright, the rate of reaction was fastest around the steepest area, and so we will say around 0.5. So right here, around here, 0.5. Steepest was around here, so 0.5 here, minutes. Why I say that? Because between 0 and 0.5 we had 6 centimeters cube of gas being produced, and after that we didn't have that much, because from 0.5 to 1 you had 5 centimeters. You subtract 6 from 11 you get 5, and then from 1 to 2 you had, let's see, 11 from 16 is 5.5 somewhere there, and then as you go you see you just decrease. 16.5 from 19, that'll be 2.5, and then between 3 and 4 that's 1. So you could see from the difference here that it was the most between 0 and 5. So this is the time interval, so I would say between 0 to 5, right? That was the fastest interval, fastest rate of reaction. So it says during which time interval was the rate of reaction fastest? Between 0 and 0.5. Produce 6 because 6 centimeters cube, or 6 cubic centimeters of gas was produced, and again that was the most gas produced between there in half a minute, right? All right, so once you have that, let's go over here. It says explain your answer. I just did. Okay, so it says that you need to explain your answer in B4. So what I would write is, at the beginning of the reaction the gradient is at its steepest, showing that the rate is at its highest. The concentration of the reactant particles is at its highest, resulting in the frequency of collisions between particles being at its highest. So I said highest like 3 times. Alright, so it says from the graph, determine the volume of gas produced at 2.5 minutes. So we go back over here and we look for the time scale, and this is 2.5, so we have to go from time. So we're going from the 2.5 right here, and we're going backwards now. So wherever we hit the line, we're going backwards towards the volume that we're looking for. And so this is 15, then we have 16, so on 16.5. So let's go against every 2. This is 16, oh 16, sorry, 17, then we have 18, okay, then we have every 2, 19, so approximately 18, so it's 16, 17, 18. So it's 18 centimeters cube or cubic centimeters, around that. Now it says use your answer in B4 to determine the number of moles of gas produced in 2.5 minutes. And it tells us the relationship here. They say 1 mole of gas occupies 22.4 cubic decimeters at standard temperature and pressure. So it's not so hard. Let's go. So it says if 1 mole of gas occupies 22.4 decimeters cube of space at STP, then X mole of gas should occupy 0.018 dm cube of space at STP. Where is it? 0.018 dm cube of space at STP, because it was in centimeters cube. So to convert centimeters cube to dm cube, you have to divide by 1,000. And to go from decimeters cube to centimeters cube, you have to multiply by 1,000. It's easy. So this is like a ratio, so it's just saying 1 over x is equal to 22.4 dm cube over 0.018 dm cube. Alright, and this is mole, by the way. So the dm cubes cancel out. So therefore, x will be equal to 1 mole times 0.018 over 22.4. And from there, we end up with 8.04 times 10 to the negative 4 moles of gas. So it says, Andrew wanted to identify the gas produced. He placed a lighted splint in a sample of the gas, which extinguished with a squeaky pop. Deduce the identity of the gas. The identity of the gas is hydrogen. Okay? Alright, so that is that for this question. Okay, let's see what they have in store. So now they said Andrew's second experiment required the use of some mass, of the same mass of magnesium, but in the powdered form instead of strips. State the factor that Andrew is now investigating. He's investigating increase in surface area. This is write a balanced chemical equation with state symbols for the reaction that occurred between magnesium and sulfuric acid in the experiment. So it has 2 marks, which means I want you to write a balanced equation and also put the states. So we know we had magnesium in the solid form plus hydrochloric acid. Acid is in aqueous form to produce magnesium sulfate, and that's aqueous, it's soluble, plus that beautiful hydrogen gas that was being collected. And it's balanced because we have 2 H's on the right, 2 H's on the left. The same ion does not split up, so it stays, and magnesium stays the same. And that's it. So it says, state one factor other than the factor investigated by Andrew which can affect the rate of reaction. Well, increasing the concentration of the acid can cause the reaction to go faster. Okay, and that would have gotten you 25 points for question 1. Okay, great job if you got all of these correct. All right, so we're on question 2. It says, when oxidation and reduction occur together during a chemical reaction, the reaction is described as redox. Some substances can be oxidizing agents, while others can act as reducing agents. Now, the equation for the redox reaction between aqueous copper to chloride and aqueous iodide is given below. First question is, define reduction in terms of oxidation states. I put both definitions. It says the one for the electrons says reduction is the gain of electrons by an element in its free state or an element in a compound. And then the one they wanted, which is the one you should have written, is it's the decrease in oxidation number of an element in its free state or an element in a compound. So that's the one they would have wanted. So just write the one they wanted. They just put the two of them to let you know they have one for electrons separate from the one for oxidation number. Then they said deduce the oxidation state of copper in copper iodide. So this is fairly easy. If you remember, the one you're looking for, you put an X, and then you know iodide is in group 7, so it would have an oxidation state of -1, and the overall state on this is 0, since we don't have a charge outside. And all we have to do is solve for X. So to solve for X, you would simply add 1 to both sides. The 1's cancel out on the left, and then 0 plus 1 will give you +1. So therefore, copper has an oxidation state of +1. Then it says define the term oxidizing agent. An oxidizing agent causes an element in its free state or an element in a compound to lose electrons. They cause the oxidation number of an element in its free state or an element in a compound to increase. Okay? Now, oxidizing agents are usually the ones that get reduced in the reaction. I know it's confusing. But just remember, up is down and down is up in chemistry. It's so strange. Now, with reference to the equation above, state with a reason which substance is acting as an oxidizing agent. Again, the one that gets reduced is the oxidizing agent. So when we look here, we see copper 2+ was reduced to copper 1 as we calculated earlier. So this that got reduced is definitely oxidizing agent, and we see here the iodide ions got oxidized from -1 to 0. I mean 0 is higher than -1, right? So it's got oxidized. Okay, so the oxidizing agent is often reduced, and reducing agent is often oxidized. So copper is the oxidizing agent. It has caused the oxidation of the iodide ions. Now, solution A was added to a small portion of an aqueous solution of potassium iodide in a test tube. The colorless potassium iodide turned brown. State whether solution A contained an oxidizing agent or reducing agent. So what I did, I wrote up a little equation to show solution A reacting with potassium iodide, and we see here that the iodide in potassium iodide became oxidized. So therefore, solution A contained an oxidizing agent, right? Once it turns brown, we know it's iodine, and that's the brown color you see there. Potassium iodide is a salt, it's a crystalline salt. It's like the salt you put in your food, but it looks like it, and so when you mix it with water, the solution looks like it's clear water, right, with salt dissolved in it. So when you hear brown came out, it's just that they went from being iodide ions, to becoming atoms, which is the iodine solution or liquid. Now, let's explain the answer in A5. It says solution A contained an oxidizing agent because the iodide ions in potassium iodide were oxidized from -1 to an oxidation state of 0. This is true since the colorless Ki solution, potassium iodide solution, turned brown, indicating the presence of I2 or iodine molecules being formed. Now it says write a balanced chemical equation to show the formula, the formation of the brown product. So I chose to write an ionic one, and also the one from what they said. So either one should be correct. So I put, we're going from 2 moles of iodide ions in aqueous solution to 1 mole of iodine plus 2 electrons to show that it was oxidized. Okay. Now, or you could have written 2 solution A aqueous plus 2 Ki aqueous to give I2 plus 2 solution A aqueous, which may not have been your first attempt. I think this would make more sense to do. Okay, so when a piece of zinc metal was added to an aqueous solution of copper to sulfate in a test tube, a chemical reaction occurred as shown in the equation below. So we have zinc plus the copper sulfate to give zinc sulfate plus copper metal, which is solid. Describe what is observed with regard to the chemical reaction that occurs in the test tube. 2 marks. So the copper sulfate solution would turn from blue to colorless as the zinc would dissolve while displacing the copper. Now the copper will become reduced and come out of solution as it would suspend to the bottom of the beaker, and you would see like brown sludge because that's the color of copper. Alright, so finishing up this question, it says one of the substances in the equation in B on page 11 is acting as a reducing agent. Describe a simple laboratory test that could be used to identify a reducing agent. Well, the reducing agent is the one that got oxidized, right? So it's going to be the iodide ions. So you could add silver ions to Ki, and it would indicate the presence of iodide ions by forming a pale yellow precipitate, and the precipitate will be silver iodide. And see the ionic reaction here. Alright, and you would see a precipitate and it would never dissolve because it remains insoluble. Okay, so that's the end for question 2. Alright, let's focus on question 3. List 3 characteristics of homologous series. Members of a series all have the same functional group. Members of a series all have the same general formula, and members of a series can all be prepared using the same general method. Okay, then it says draw the fully displayed structural formula for compound A, which is the molecular formula C3H8. So if you can't see it, it's literally C3H8, and if you see it's 1, 2, 3, and we have 8 H's, so 6 in the center and 2 on the ends. State the homologous series to which compound A belongs. Alkanes, because we have single bonds existing between the carbon atoms. Then it says write the molecular formula for the compound which has 5 carbon atoms of the homologous series stated in B2. So then it would be pentane, and because the homologous series for alkanes is CnH2n plus 2, I would say 2 times 5 is 10 plus 2 gives you 12. That's how I know. Okay, now it says draw, and that's what you call the general formula for alkanes. Then it says draw the fully displayed structural formula for compound B, which has the molecular formula C3H6. So this one is CnH2n. So this one tells us the general formula tells us that this is an alkene. So therefore we're going to have a double bond in here somewhere. And if you count, we have 3 carbons and we have 6 hydrogens. Awesome. So it says state the homologous series to which compound B belongs. Alkenes, just because of the general formula. It says write the molecular formula for the compound which has 5 carbon atoms of the homologous series stated in C2. And that will be C5H10. And again, since this is CnH2n, this is the general formula for alkenes, we'll say, well, if n is 5, then 2 times 5 will give us 10. And that's how we work that out. Now for each of the following homologous series, write the general formula. So for carboxylic acid, it will be CnH2n plus 1 COOH. And this is the functional group for the carboxylic acid, COOH. And then for the alcohol, we have here CnH2n plus 1 OH. And the functional group is the OH group. So, yeah, it should be R. Let me rub that out. There's supposed to be R right here. So this is the functional group right here. Then it says name the first member of the carboxylic acid, and that will be the single C, single carbon. So that will give us methanoic acid. And we just add the H here. And then for alcohol, we just change it to methanol. So methanol would be literally like this. So it would have a single carbon atom, right? And that would have given you your 15 marks. So if you're not good at organic chemistry, I suggest you read over your text and visit my website, thescienceofskb.com, to find the textbook there. The textbook you should be using is the Concise Text by Collins, the CXC Concise Text. I think that the CXC examination is written based on that text. Okay, so feel free to read that chapter on organic chemistry. All right, so we're finally on section B, and we're going to be doing question 4. This is not such a hard question, but it still appeared to be, especially if you haven't learned electrolysis or grasped it well. But let's go. So it says, Jack was required to conduct an investigation on the electrolysis of concentrated sodium chloride solution. It says identify 2 ions present in the electrolyte and include their state symbols. So it was a concentrated sodium chloride solution. So it could either have, it could have all of these. It would have sodium ions, chloride ions, hydrogen ions, and hydroxide ions, but they only asked for 2. And I picked the ones that were of interest because they emphasize concentrated sodium chloride. So I put the 2 ions of interest. It says state 2 factors that affect the discharge of an ion in the electrolyte during electrolysis. So first of all, it will be the position in the reactivity series. So remember, the lower down you're found in the reactivity series, the more unstable you are. So you would come off first. And then we have the concentration of the electrolyte as well. That determines what usually comes off at the anode. Yeah. For especially halide ions, right? So it says predict which ions present in the electrolyte will be attracted towards anode. And because it's a concentrated solution, it wouldn't be the hydroxide, and it would be chloride ions. So for the anion reactivity series, I usually say Fiona never comes by in October. So I just add my negative signs. Chlorine, bromine, iodide, so yeah, chloride, bromide, iodide, hydroxide. Even though the hydroxide anion is to the bottom, remember we said concentrated. So again, for the anions, you would just say that chlorine will come off because it's concentrated. It says write a balanced equation for the reaction at the anode. So remember, it's an anion. Anions are attracted to the anode. And so you would have 2 moles of chloride ions, because it's in solution, would become oxidized to form chlorine gas. And seeing as how it's an oxidation, we would have 2 electrons here. Usually this is how we write it. You write it like this first, aqueous. And since you have a negative sign here, you put negative here, and you have 2 electrons, so 2 electrons to give the chlorine gas. But guess what? In chemistry, we don't like negative signs, so we do it like an equation. We just get rid of the negative from the left side, and we add it to the right side. So we have a neat equation, and that's what we have. Voila, up here, 2 points. All right, so write a balanced equation for the reaction at the cathode. So remember, cathode, cations, so hydrogen will come off because we don't really do concentration for cations like that. So we know hydrogen will come off there, and we end up with 2 hydrogen ions, plus, since it's a reduction, we're going from +1 plus to 0. Once you have a molecule and no charge, is 0, so it's a reduction. So we have the addition sign here. And usually to do this, I would tell people, once the plus, you put a plus back, and then you count the electrons that are going, and you put 2 electrons, and then you go there. Yeah. All right, so state whether each of the substances given in table 2 are classified as conductors or non-conductors. So if you didn't know this, well, here is your time to shine, because they want you to state whether you have a conductor or non-conductor, which should be real easy. So magnesium, we know it's a metal, so it's a conductor. Plastic ruler, non-conductor, hello, it's plastic. And then we have a solution of ions, which is known as an electrolyte, so that's a conductor. Now, carbon is an example of a non-metal state. To use of carbon, well, it can be used as a lubricant. It can be used in your pencil point for writing. It can also be used as an electrode or conductor. Carbon can be used as a conductor because carbon is special. Well, carbon in a special form, for instance, as graphite. So I should put graphite in brackets here, and graphite in brackets here as well, because it has to be as graphite, because carbon bonded in the way it is bonded for diamond wouldn't conduct electricity. No. Okay, so we're on to question 5. It says, compound C is a sweet smelling compound which is often used in flavoring and perfumes. It says, state the name of compound C and the homologous series to which it belongs. Well, when you're naming this, you name this part first. Well, the part that doesn't have the double bonded O to O. So this is methyl, and then you count these 1, 2, 3. So it's a methyl propanoate. And so once you see it look like this with a double bond O, and then you got this extra R group down here and this one up here, it's an ester. Okay. Then it says draw the fully displayed structural formula of the 2 molecules that are produced when compound C is hydrolyzed. And of course, you're going to get back the carboxylic acid and the alcohol that the ones were. So you're going to get propanoic acid and methanol. Then it says ethanol is widely used as a solvent for making cosmetics and perfumes. It says state the name of compound D and identify the reagent and conditions necessary for ethanol to be converted into compound D. So the name of compound D is actually ethanoic acid, because you have 2 carbons here, which is ether. And then since you have the functional group OOH, COOH, it will be ethanoic acid. Now the conditions to go from the alcohol to the acid will be acidified potassium manganate 7 or acidified potassium dichromate 6. So either one is fine. Just make sure it's acidified. Then it says, now explain how ethanol can be made from the fermentation of sugar. Include the chemical equation for the overall fermentation process. Well, once you have glucose and you add some yeast at a temperature of 37 degrees Celsius, what we produce is alcohol and carbon dioxide. And as you can see here, I wrote it here. C 4, 5, 6. Yes, everything is balanced. And it says ethanol can be produced by using yeast to ferment carbohydrates under anaerobic conditions, which means without oxygen. Glucose is a simple sugar that is broken down by the yeast zymase in a process called fermentation. Fermentation stops once the concentration of ethanol reaches 14%. Now, at this concentration, fermentation stops because it begins to denature the zymase and stops it from working. Right? Denature means to destroy. Now, via fractional distillation, the ethanol can be obtained from the fermentation mixture. It says state one of the use of ethanol, and it will be to make alcohol that is used in wines. That's the only edible alcohol of all of them. The rest of them will poison you. Now the last question, finally, we made it to the end. It says many metals undergo corrosion when exposed to certain conditions. Figure 2 shows an experiment where iron nails are exposed to different conditions. So this is something you would have done if you did INTI. This is something they do all the time as a lab. So it says state the 2 conditions necessary for the corrosion of a metal. First of all, I need air and moisture, 2 max, and they give you 1, 2, 3, 4 lines. Then it says state whether corrosion will occur for each of the test tubes shown in figure 2. Give 1 reason to support the answer in each case. Oh my God, if you never knew what this is, you have to be guessing your way through. This is so sad. I know you know. So in test tube A, corrosion will occur since the nail is being exposed to air and moisture. In test tube B and C, no corrosion will occur. The reason being for B is that since the nail is only being exposed to water, there is no moisture attacking it, and the reason why it's only exposed to water is because it's covered by a layer of oil which is blocking the air from getting to the nail. And for test tube C, no corrosion will occur since the nail is only being exposed to dry air, which means that there's no moisture at all in the air. Okay? Then we have here, suggest the reason why the boiled water was covered with oil in test tube B. It was covered with oil to avoid, to create a barrier for the air, to stop the air from getting in there, into the water, to cause corrosion. Now, aluminum has been used in the manufacture of various alloys because of its corrosion resistant properties. State 1 alloy of aluminum and its use. Well, duralumin, which is 94% aluminum, 4% copper, and small amounts of magnesium and manganese, used to construct aircrafts and bodies of motor vehicles. Then 2, explain why the corrosion of aluminum is beneficial. 1, it makes the aluminum stronger. 2, it can be painted. And 3, it makes the aluminum harder. At this point, I was so tired. I feel your pain, students, to have to write so much during exam. I'm going to draw a tear from my eyes. Right here for you. 1 tear. 2 tears, 3. I feel the pain. And then it says here, write a balanced equation to show the product formed when aluminum is left exposed to air. So this is the best I could do. I wrote the one that I know, aluminum solid react with oxygen to give aluminum oxide. And that's it. I balanced it. So if you look at it, what I usually do for balancing, I write down the atoms involved, and so it's the same atoms on the left as they are on the right, aluminum and oxygen. If you see here, we have 4, and then 3 times 3 equals 6, and over here we have 4, 2 times 2 is 4, and 2 times 3 is 6. So we are balanced, and my dears, that is the end of the test. How did you do? I must say difficulty for this test, what would I give it? On a scale of 1 to 5, 5 being the most difficult, 1 being the easiest, I'll put this close to 4. Reason being, the test covered topics that people usually skip over. Yeah, usually skip over those topics like oxidation, reduction and oxidation, and like things like these, metals in the environment and stuff like that. So be sure to read your textbook, please. And also electrolysis. Electrolysis is often a skipped topic, and it's also the most misunderstood topic. To wrap your mind around ions coming out of solution is hard enough. So props to you if you understood everything on this test, or at least you tried it along with me. And that's a wrap. Bye.